Welcome to Ask and Learn.
Okay, so we want to prove that the following formula is true, but checking that this is the different ways of counting the same thing. So we want to think about this as all the ways we can select k elements and distinguish two of them, that it could be the same. So let's think about it this way. So we have n balls in a box. We want to select k of them, and from those k's you're going to choose your favorite and I'm going to choose my favorite. So let's see how we do that. So we know that each time we can select from the n balls k, and I have k options for my favorite and you have k options for your favorite, that it could be the same. Okay, but this is only for one choice. How many ways can we choose this element? Well, we could choose 0 of them, we could choose 2, we could choose 1, until n, because that's the amount that we have. So this is all the ways that we can select some balls from the box, and you choose your favorite and I choose mine of that selection. Okay, so that's what this first side means. Now, does the second side means the same? Well, it's not that easy to see it on this expression, but it's going to be somewhere easier to see it in this side. Now, I know this is a little bit hard later to explain on your homework, for example. Try to write with words on what we are explaining. So now suppose that we are looking at the n elements, okay? This is each one of them. And the first thing I'm gonna do is I'm gonna go ahead and select my favorite. Let's say that my favorite is the last one. So I selected this and I say, hey, let's first, I choose one and you choose a different one. So I have n choices for my favorite. And since I don't want you to choose the same that I chose, you have n minus 1 possibilities for yours because you have one less. So now we've selected our favorites and we have n minus 2 left. And then we are going to decide if we want them or not. So I'm going to put a 1 if we want it to be selected and a 0 if it's not. So for sure we're selecting the ones that we like. And then we randomly decide to choose or not choose the rest. So for each one of them, we have two options. We decide to put 0 or 1. And we are assigning zeros or 1 for n minus 2, for the leftover. So we have n minus 2 2's. That gives us the first term. Now I say, okay, since we before decided to choose a different one, let's choose the same one now. Okay, I'm a little bit bossy, so I'm the one who's telling you what to choose. Huh? Okay, so we have n elements now, and we are both going to choose the same one. So we decide that this one is the champion. So we had n options for that one because we could choose any of those n. And now we have n minus 1 left, to which we will assign a 1 if we chose it, a 0 if we didn't. Okay, so for each one of them, we have two options. And since there are n minus 1 of them, there is n minus 1 options. Okay, so what we have here is exactly the same that we have in the hint. Okay, so for what we have talked about, we prove that these two things are the same. Now the question is, can I write the last one as something related to this? And the answer is yes, and it's not too bad because we can extract that n from both of them. And we can actually also extract 2 to the n minus 2 because we have n minus 2 here, n minus 1 there. So there is more actually here than there. And so what we have left is from the first one n minus 1. And from the second term, we have 1, 2 that is left. And that is actually n plus 1. So we have n times n plus 1, 2 to the n minus 2, proving that this identity is true.